Today's lesson is on section 4.2, graphing linear equations. So far in this chapter we covered section 4.1, which is a little bit of a review of plotting points and getting a little bit of graphing. What I'm going to mention today is in this entire chapter we're going to learn three different ways, as it kind of says up here, three different ways to graph an equation. But right now, if you're taking notes along with me, I want you to jot down the first of the methods that we're going to talk about. And again, I may have touched on it a little bit in the last lesson, but I'm going to really focus on it here, this particular lesson, 4.2. The first method we're going to talk about for graphing equations, first method we're going to learn is the method where we find some ordered pairs or find some solutions to that equation, and we plot those ordered pairs like points on the coordinate grid. And again, we've been reviewing that so far, so we kind of know how to navigate that right now. This method, finding solutions, finding ordered pairs for an equation, it's always going to be one that works. We're going to learn other methods as well that work just as well, but I mean, sometimes even a little faster. But finding some ordered pairs will always work. And sometimes I think of this as like the nice fallback one. Like it's the one you should learn first, so you can kind of understand what's going on with all the solutions we're finding and what the line really represents. And then once you've kind of learned that, then learning the other methods that may be a little quicker, well, those are very good methods too. But this one's always going to work. It's always a good fallback. And I think it's one that you'll use even in the future when you're learning how to graph newer equations as well. So looking at one like this, again, how does this work? How do I find some ordered pairs to be able to graph an equation, let's say, like this, y equals x minus 5? Well, again, what we're looking for is ordered pairs. Those are solutions to this particular equation, this specific one, y equals x minus 5. So, and I'm going to use this table to organize my ordered pairs. Again, another way you can write them, though, is just in parentheses as a comma, but what we're looking for is an equation like this. We're trying to find solutions for this equation, remember. So since there's two variables, there's x and y, I can put in some number for x, and it'll give me a solution for what y could be. And then I could put in some new number for x, and it'll give me another solution for y. So, and then talking about this in a previous lesson, we find out that there's an infinite amount of answers for a problem like this. And all we need to do is if we find a few, we can plot those on the grid, and I can use those few to help me draw a line that will show me all the solutions for this equation. So for example, looking at this though, y equals x minus 5, let's find some solutions. And what I typically tell students to do is, well, let's pick out some values for x that we could put into this equation, and I'm going to take those values, subtract 5, and that's going to give me what y would have to be to make a good solution for this equation. When you're picking out values for x, you can pick out whatever you want. It doesn't matter. You can pick out, again, as I tell students, 0, 1, and 2. You could plug all three of those in and find some ordered pairs. You could pick out 4, 5, and 6. You can pick out 40, 50, and 60. It really doesn't matter. You can pick out whatever solutions. Again, no matter what number I put in for x, I'm going to find some solution, or what y could be to make that a good solution. So, but I always do say 0, 1, and 2. Okay. You can pick out whatever you want, but 0, 1, and 2 are just kind of usually pretty nice ones we can plug into the equation. Pretty easy ones to evaluate. So I usually stick around those numbers. So again, what happens here? Well, if x is 0, what would y have to be to make this equation true? Well, 0 minus 5 would be negative 5. So when I put 0 in for x, I get that y has to be negative 5, and that'll make the equation true. So there's a solution to this equation, 0, negative 5. Again, this is what I'm doing. I'm finding solutions that work for this equation, and they're just like ordered pairs. That's what they are. A solution for this particular equation here. If I put 1 in, y equals 1 minus 5. Well, 1 minus 5 gives me negative 4, so I get negative 4 for an answer. And if I put 2 in, 2 minus 5 gives me negative 3. Now I've found three ordered pairs. I'm always going to ask you when we use this method, I always want you to find three different ordered pairs and kind of explain why. As we'll find out, we really only need 2 points to make a line, but if you find 3, it's kind of like a check for yourself to make sure. All 3 of your points, whenever you're graphing an equation like this, whenever you're graphing equations, all 3 of your points should line up. They should be in a nice straight line. If you end up getting something where it's a point, and then some point over here, and you get this triangle shape, then something went wrong, either with plotting your points or when you plugged in your x-coordinate to find out what y should have been. So finding 3, though, can kind of make you double check and make sure. If you just find 2 and one of them's wrong, well, then you're not going to know if your answer's wrong. So So finding 3 can help out a little bit to make sure we're on the right track. Now I'm going to plot these points. 0, negative 5. Where is that point? Well, again, along the x-axis, I go left to right 0, and I go down 5. 1, 2, 3, 4, 5. So there's the point 0, negative 5. Left to right 0. Y-coordinates negative 5, so I go down 5. 1, negative 4. I go to the right 1 and down 4. There's my point. 2, negative 3. I go to the right 2 and down 3. So there's my point right there. I have those 3 points. They seem to line up nicely. I'm going to draw my line all the way through the grid. And it should go all through all 3 points, and yes, it does. Again, what does this line represent? This line is showing us all possible solutions for this particular equation. There's an infinite amount of them. I could find some more combinations. Like if I find a combination, let's say if I plug in 8 for x, okay? 8 minus 5 would give me 3. So this also should be a point that's on that line. And if I've drawn it nicely here, we'll see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. I was pretty close. But yeah, if I drew that line perfectly with a ruler, it would go right through that point, 8, 3. Okay. Again, I could find a bunch more. I could find some point way off in the future, 50, 47. Okay. 50 minus, 50, 45. I was thinking of another problem. 50, 40, 40, yep, 45. I'll get it right. There we go. 50 minus 5 gives me 45. If I plotted that point way out, 50 to the right and 45 up, I would find this line. This line would still go through that at some point. If I kept going, at some point, that point 50, 45, got it right that time, that point would be on that line. Again, this line will go through all the possible solutions, all the possible combinations for x and y that work for this equation. So that's what we're showing when we graph an equation. It's a visual representation of all the possible solutions that work for an equation. Just showing another example here, y equals 2x plus 1. So again, we're going to graph this equation using this method. We're just going to find a few solutions, 3. We're going to find 3 solutions, 3 ordered pairs that work for this equation. And using those 3, I can draw a line that would show all the possible solutions. Again, you can plug in 0, 1, and 2. You can plug in 3, 4, and 5. It doesn't matter. I'll plug in 3, 4, and 5 in this time. Okay, just to show you that, again, I can plug in whatever I want for x. I'm just going to suggest you plug in 3 to make sure that your 3 points line up. So if I put 3 in, for x, I'd have 2 times 3 plus 1. Well, 2 times 3 is 6, plus 1 gives me 7. So 3, 7 would be a point. If I put in 4, 2 times 4 plus 1, that'd be 8, plus 1 would give me 9. And if I plug in 5, 2 times 5 is 10, plus 1 gives me 11. So that I could find those 3 points, 3, 7, 4, 9, 5, 11. Plotting those, again, these are solutions to this equation. So if I plug in 3 for x and 7 for y, it'll make the equation true. Okay. If I plug in 4 for x and 9 for y, that'll make the equation true. So again, these are solutions that work for this particular equation. And I can show me all the rest of them. So 3, 7, I'm going to plot them. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 4, 9. Here's 4, 9. And then 5, 11 goes just a little bit off my grid, but I can imagine it's about right there. Okay. Now again, if I draw a nice straight line, and I'll try to here, do my best. That line is showing me all the possible solutions for this equation. We'll talk about in class 2, why does the line have arrows on the end? Why are there arrows on each end? Well, like we talked about, how many solutions are there for this particular equation? There's an infinite amount. So yeah, your grid doesn't extend until infinity, but these arrows are telling you that the lines go on and on forever. These go on and on forever with more and more solutions in each of the 2 directions. So that's what those arrows are standing for, and that's why we do need them on the line. It's representing all the possible solutions, so we do need to include those when you're graphing. Make sure to put arrows on each end of your line. Again, like we did before, I could pick out some other solutions. Again, here I picked out 3 solutions. These all work. And just a reminder, you could write them like this as well if you want. If you're not a big fan of the table, or if that kind of confuses you, to remind you what these really mean, yeah, these are like 3 combinations, 3 ordered pairs that work for this particular equation. But if you want to write them as ordered pairs with the parentheses around, that makes more sense to you, that's okay too. Just showing though again, I could pick out some numbers. And again, if I've drawn a nice line, I think I've drawn a pretty good line here. I could pick out some other value of x, like let's pick out some negative number, like how about -3? If I put -3 in for x, I'm going to get -3 times 2, which is -6, plus 1, which gives me -5. So let's see if the point -3, -5 is on this line. 1, 2, 3, 1, 2, 3, 4, 5. What do you know? I drew a pretty good line this time. So there's the point -3, -5, and it should go perfectly through that point as well. And any other point that ends up being a combination, that'd be a solution to this equation. Some kind of ordered pair. Any ordered pair that I could plug in for x and y in that equation should be on this line. Just going to show you one more little trick here when you're using this particular method. So for an equation like this, like y equals 1/2 x plus 1, sometimes we will see numbers, or we'll see fractions in our equations, and we'll have to graph them. Now again, in the future, we're going to learn a method that makes it very nice for when we have fractions in our problem. There's a very nice, very smooth way to graph these. But for now, using ordered pairs method, I got to pick out some values for x and y and find some ordered pairs that work in this equation. And sometimes, well, sometimes I know students working with fractions, it kind of bothers them, or they don't want to end up with numbers that are decimals or other fractions. So that's okay. I can give you a little hint here on picking out some good numbers. In this problem right here, it says 1/2 times x, right? When that 1/2 is right next to the x, it means you're going to multiply times whatever number you put in for x. Well, if I'm going to take half, really multiplying by 1/2 is like dividing the number by 2 or taking half that number. So if you're going to take half a number, what kind of numbers would be good to plug in for x so that when you take half of it, you won't get a rational number or a decimal number? Well, usually I'll ask this to students in class, and they can usually give me a bunch of examples, like 2 or 4 or 6 or 8 or 10, and then I'll have somebody generalize, and they can usually say, oh, I'll pick out some even numbers. And that's the answer. Yeah, if you pick out some even numbers, if you see a fraction like 1/2, or just numbers that you can divide by 2, because the denominator there is 2, if I pick out numbers that I can divide by 2 evenly, then that'll give me some nice numbers that I could plug into this equation and find ordered pairs that are still all integer answers. Now, do you have to? No. I mean, I could plug in the number 3, and if I put 3 in here, 1/2 times 3 plus 1, well, 1/2 times 3 would be 1.5, plus 1 would be 2.5. And I can plot that point as well. 3, 2.5 is over 1, 2, 3, up 2.5. I mean, there's that point, so I can still plot it. But if you're concerned or you'd like working with integers more, then again, I'd pick numbers that are, in this case, like I said, this problem, we can pick numbers that are even. If I pick, the number 6, half of 6 is 3, and then adding 1 would give me 4. So I can get the point 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Or again, if I even picking out 0, 0 is always a good number. 0 times 1/2 is just 0, plus 1 gives me 1. So 0, 1, there'd be that point. Again, here's 3 points. They all line up. Whether they're rational numbers or integers, it doesn't matter, but just a suggestion. If you want to pick out numbers, if you happen to have a fraction in your problem, we'll pick out some numbers, like I said, in this case, numbers that are even would work when 1/2 is your fraction. If you have some other fraction, like this one more, just example to show you, what if it's like 1/4? Well, then again, 1/4 times x is really like putting a number in and dividing it by 4. So what kind of numbers will we pick out? Well, numbers that we could divide by 4 evenly. And so students, again, after a little bit of thinking, sometimes they usually come up with, well, I could put in 4 or 8 or 12 or 16. I can put in some numbers like that. Let's say the problem was y equals 1/3 x. Well, then what kind of numbers would I pick out for x then? Well, then usually we pick out numbers like 0, 3, 6, 9, 12. Okay. We'll find, okay, well, I should pick numbers that are divisible by 3. So just a little tip that may help you when you're graphing for ordered pairs method. Again, this is the nice thing about an ordered pairs method, is that I can pick out any numbers I want. I don't have to pick out 0, 1, and 2 every time. Again, those are kind of nice standbys. But no, I don't have to. I can pick out any numbers I like for the solutions. So pick out numbers again. Sometimes that will make it more helpful for you. And again, if you like working with integers, just we'll pick out some numbers that'll give you integers, even when you have a fraction in your problem.